Hello everyone, welcome to this session on Introduction to Statistics, and this is our 20th session, right? Day 20, and we are discussing about the measures of central tendency, right? So that too for group data, and we already started how to find. So we are starting with the mean. In that also, in the previous session, like session number 19, we discussed about the there are three methods are there, right? Direct method, assumed mean method, and step deviation method. So we are already done with the direct method. So now here in this session we will be focusing on the other way, another method. So assumed mean method. So this is going to be our focus in this session. So like you might be asking, like, so we have already one method, direct method, which is a very simple and straightforward. So why we want to go for the another method, alternative method, right? So for example, see, in the direct method what we have done, right? If you remember, in the direct method, so we use the formula. What is the formula? X bar is equal to sigma fi xi by sigma fi, right? So this is the formula we use. In that, what we have done, so we have already the given data, the class intervals. Then we have the second column as the frequency, the number of students. Then we found the class marks, that is denoted with xa. Then in the fourth column we took the product of f and x, right? This is very simple and straightforward, right? So then we take the sum of fi x and then divide with the sigma fi. So the concept, the core concept remains same, right? To find the mean, so we, what is the formula? We even use it for the ungrouped data. So what is the formula? Sum of all observations divided by the total number of observations. The core concept is remains same, right? The only thing is that we have the different kind of data here, group data, right? Now here what will happen? See, as in the fourth column we are taking the product, right? Suppose if fi and xi are very large, right? If these numbers are very large, so what will happen to their product, fi into xi, right? Obviously this product also will become very large, right? So because of these large numbers, what will happen? Our calculations will become tedious, right? And also because of those large numbers, the multiplication of those two again large numbers, it takes time, right? So therefore they are time consuming, right? So what we wanted to do, so we wanted to reduce these calculations. We want to make things very simple. We want to get the numbers very fast, right? So therefore for that purpose, what we have the alternative method, that is a assumed mean method. Clear? So in this we are not going to change very much. The only thing is that we want to make it calculations very simple. So that is what our focus. So as we know, right? So before going to start, let us take the table. Then we will I will show you the calculations with the like each and every calculation clearly. Okay. So let us construct the table by so we need 5 columns, and then so as of now, so I'm taking the table, then we will add accordingly requirement. Okay. So here, so what is the first column? So that will remain same, right? Class intervals, and then second column will be remain same, the number of students, right? So we know, right, the number of students are denoted with fi. Okay. Then we have the other, that is class mark. So it is denoted with xi, right? So this is till the direct method, right? So let us write the values, then I will show you the extra. Okay, so what is the first class interval? 10 to 25, and then 25 to 40, then 40 to 55, and then 55 to 70, then 70 to 85. Okay, so we need to add one more column, so let us right click and go to the table, insert below. Okay, so I need one more column, because if you remember, in the direct method we supposed to take the sum, right? Sum of the frequencies and the sum of the product, so for that purpose. So here 85 to 100, so this column I'll keep this column, the last the row, last row I'll keep it to take this sum, right? So here what I need is that, so till here there is no change, so the same as it is, like how we have done in the direct method, similar way, so we are going to do. Okay, so you know, right, how to find the class marks? You just to take the sum of the lower limit and upper limit, right? So that is here, if you remember, so I am again repeating. So for example, so what is the class interval here? 10 to 25. So how I can find the class mark for this? You just take the sum of these two numbers, so that is 35, then divide with 2, so that is equal to 17.5, right? So that's how we find the class mark for each class interval. So I'm writing from the previous direct method only, so 17.5, then the next will be 32.5, then we have 47.5, then 62.5. Okay, so next 77.5, and then we have 92.5, right? So this is a same, so I did nothing new, right? So till from here to here, direct method, right? So now instead of taking the product of this fi and xi, now what I am going to introduce? So I am going to introduce one number called deviation. Okay. So here deviation. So that is di I am denoting. So that is nothing but, so I am taking the xi, that is my observation, and then I am taking a one assumed mean as a. So here see, in this assumed mean method, what we are going to do? So earlier we have already fi, then xi, then we have taken the product of fi xi, right? So now instead of proceeding for this step, no, so I don't want to go. So what I am doing, I have already fi, then xi. Now here I am taking the third column as a di, that is the deviation. Okay, how I can find the deviation? I am finding the deviation from the each observation, that is xi, from one standard assumed mean. So I am assuming that as a. So now how we will how we will select this a? What is this a represents? So this a represents assumed mean, right? So this assumed mean is coming from the one of the class mark, one of the class mark, right? Now the second question you might be getting, so which class mark I should consider as a, right? So because this a will be the remains constant for each class interval, right? So which class mark I should consider as a, right? So you can consider, so there is no restriction on the selection, right? You can consider any class mark, any class mark as your a. Okay, but I will tell you, but instead of choosing anyone, so we generally try to choose the middle one, the middle number as our a. Why? So I will tell you the advantage of choosing middle class mark as your a. So I will show you the benefit of that. So now here what we are going to do now here, so di. So for this di, for the first class interval, what is your xi? That is 17.5. Now what is our a now here? So a is our here 47.5. So this is our a. Okay. So now minus a. So that is a 47.5. So how much it is? Minus 30. Clear? So that will be your di for the first class interval. So I am writing here minus 30. Okay. Now for the second one, for that means this one. So 32.5 minus 47.5 is how much? Minus 15. So that will be our here minus 15. Then next, now you see here 47.5 is xi. Then we have the mean 47.5. So this will give us 0, right? Now look at the advantage. So when you take the middle one as your class mark, a. So what will happen now? 62.5 minus 47.5 is how much? So it would be 15, right? Clear? So that 15 will be here. Now what is happening here? Simply earlier here you have minus 15, so then you are getting 15. So without even doing so, you can write it directly here. It will be 30, right? So then it will be in the incremental. So therefore, so then it will be 45. So that is the advantage, added advantage if you choose middle number, middle class mark as your a. Clear? So then now next we need to take the product. So what is the product we need to consider? The product is, so we are already having the frequency fi. Then instead of xi, so we are considering the di. Clear? Now here, now you see these calculations are very simple. 2 into minus 30, that will give you minus 60. 3 into minus 15, minus 45. 7 into 0, 0. 6 into 15, that is 90. 6 into 30, 180, right? So these compared to the previous numbers, so these numbers are very easy to calculate, right? So 6 into 45, that is 270. Okay. So we are done with the table, right? So now you just take the sum. So this is our the final row. So here I am taking the sum of all the observation, that is sigma fi. So that is 30, right? So now here I need this, I need the sum of this, right? So what is the sum of this? So I'm denoting that with the sigma. So what is the sum? If you take the sum of all these numbers, that will give you 435. Okay. So now we are done with the table and we are done with all the calculations. Now you can here clearly see, right? So there is a instead of here the calculations are became very simple compared to the previous one. So now our mean, the formula in the mean deviation x bar, that is equal to, so we have taken a, right? The assumed mean. So I am going to add that a plus, now because as I reduced the values, right? So the summation, that is fi di, summation of this product, and when you divide with the total number of observation, this number will become very small, right? and for that I wanted to add the middle number, assumed mean. I assumed one number as mean, then I am taking the deviation, how much deviation is from that mean assumed. So that is calculated from this part. Okay, so here 47.5 plus, so 435 divided by 30. Okay, so if you do this calculation, so this will be equal to 47.5 plus, so this number will give you 14.5. Okay, so if you take the sum, so that the sum will be 62. So therefore your mean x bar is equal to 62. If you see, we got the same number from the direct method. Clear? So therefore here the only thing we use this method is we want to reduce the time taking for the taking the product of fi xi, right? So therefore we introduce the deviation, that is the fourth column, right? So then we replaced xi with da, then we did the rest the same how we proceed to find the mean. Okay, so that's how we calculate mean by using the assumed mean method. Okay, so that is all for this session. Okay, so thank you, and kindly I request you to like, subscribe and share. Okay, thank you. Okay, thank you.